Hi students, it's Miss Demaro, and now we're going to talk about function notation. So I'm sure you guys remember function notation from last year. F of x can also be written as p of x. P just stands for polynomial. So sometimes you might see p of x. Okay, in our first example, it says we want to divide 2x to the fourth minus 15x squared minus 10x plus 5, and we want to divide by x minus 3. So we're going to do some synthetic division. Remember, the root is 3, so that's going to go in the box. And then I'm going to set it up in order. I have a 2 for my x to the fourth, but I don't have an x to the third, so I have to put a 0. And then I have negative 15, negative 10, and 5. Okay, we're going to bring the 2 down. And remember, we multiply. I get 6, and then we add. 0 plus 6 is 6. Multiply, 18. Let's add. I get 3. Multiply, I get 9. Add, I get negative 1. Multiply, I get negative 3. Add, I get 2. So my answer is 2x to the third plus 6x squared plus 3x minus 1 with a remainder of 2. That looks familiar. We might have already done that one. But this part says find p of a using your calculator. So let's say I want to find p of 3. So if I'm going to type that in my calculator, what answer would I get? So take a minute, type that in your calculator. You should get 2. Interesting. All right, let's try another example. So we want to divide 6x to the third plus 11x squared minus 4x minus 4 divided by x plus 2. That looks familiar also. I think we already did that one. Let's see, p of a. So we want to do p of negative 2. So what would that mean? That would mean I would take negative 2 and plug it in for x. So I would have 6, negative 2 to the third, plus 11, negative 2 squared, minus 4 times negative 2, minus 4. Oops, negative 2. There we go. Make sure you're using your parentheses. So I'm going to plug that in, and I get 0. Again, we did that example before. Let's see. All right, example 3, you try. Now, I do believe this is a new example, so take a minute to do number 3. It is using synthetic division, and then you want to find p of a, which in this case is going to be p of 2. Now, read the question. Okay, so you're going to pause the video, try that question, and then let's take a look. What is the relationship between the remainder from synthetic division and p of a? Is there a relationship? What you should notice is that they are the same. So in example 3, if you pause the video, you should have gotten negative 11 as your remainder, and when you plugged in 2, you should have also gotten negative 11. Okay, that leads us to a theorem. The remainder theorem says when a polynomial p of x is divided by x minus a, the remainder is p of a. So in other words, if you want to divide and you just want to know what the remainder is, you can take your root and plug it in, and that will give you the remainder. The factor theorem says for a polynomial p of x, x minus a is a factor if and only if p of a equals 0. So in other words, if you plug your number in to get the remainder and you get a remainder of 0, you know it's a factor. Should you use synthetic division to find p of a, or should you use direct substitution? Well, obviously the easier way to do it is to plug the number in, but a lot of times it depends on what the question is asking. So it depends. Sometimes either is okay, but sometimes one method is easier. Usually it's easier to plug the number in. If you have a really high power, you don't have a choice. You don't want to do synthetic division if your highest power is 100. But you also must read the question. If the question says to divide it and to write your quotient and your remainder, then you have to do synthetic division. Thanks. See you next class.